Absolute value will work with a lot this year, so it's important that you understand the definition. If the inside is positive, then it's as though we're removing the bars. But if the inside is negative, and this is the way to say that it's negative, then we're taking the opposite of which we see, so it would be negative A. And I realize the first one is easy to understand. Let's look at a simple example for the second one. So if the inside was negative 3, you know the absolute value of that is positive 3, but what we're really doing is following definition, which is negative of what's inside, which is how we generate positive 3. So next we're looking at the parent graphs, but I want you to have the formulas for each of them so that generically you know what they are. So this first one, even though that's the parent of all quadratics, of course the generic form is y equals a times x minus h squared plus k. And of course these all will look very similar. So when I move over to the cubic, it is exactly the same, except it's a x minus h cubed plus k. And keep in mind, for both of these functions, hk tells us something very important. For the quadratic, of course, it's the vertex. For the cubic, it's down here. For the cubic, it's actually this point of inflection. And I usually call that the poi. Of course, similar for the degree 4 polynomial, the only difference being that the x minus h is raised to the 4th. That 4 doesn't want to finish. And of course on the degree 5, it's the only difference is that I have a power of 5 on the x minus h. So they all work very similar. Of course, one thing to keep in mind is not all degree 4s look like a parabola. They could look something like this, or it could look something like this, or it could even look something like this. So lots of options. And then of course the degree 5, same thing. I could have something that looks, here's another xy axis. I could have something that looks like this, or I could have something that looks like this. So any of those are options. Of course, the important thing to remember is, or a giveaway is possible to figure out what degree it is by looking at how many turns it has. So since this one has 4 turns, then the degree would be 1 more, which is 5 at a minimum. This blue graph could also be a degree 6 or a degree 7, but at a minimum it has to be a 5 because there's 4 turning points. So 4 turns plus 1 tells me what the minimum degree is. Just like over here on this first one, when I'm looking at the green graph, I have 1, 2, 3 turning points. So 3 turns plus 1 means I have a minimum of degree 4. This could be a degree 5 or a degree 7, something odd. We'll talk about the location of the endpoints as we move through the functions. Your square root function, again, follows the same pattern. So generically it would be y equals, and then I could have an a value out here, and x minus h, surprise, it's the same letter, and then plus a k out here. And so again, hk on the square root function is a vertex. See you on the next video. I'm out.